Calculus, Video 10, Properties of Limits. So we have 5 properties of limits that I want to share with you. And what I want you to think about these properties of limits as is, here's some things that I'm allowed to do with limits. Right? We will use these properties within solving other problems. Right? So here's some things you're allowed to do. Here's 5 things you're allowed to do with limits. Number 1. If you have the limit as x approaches a of 2 functions, f and g, either added or subtracted together, right? So here we're looking at a function f of x and a function g of x, and those functions are either added or subtracted together. What you can do instead is separate that and take just the function, just the limit of f of x, and then add or subtract that to the limit of g of x. All right, so for example, kind of scroll down here. From that example 1, if you had, say, the limit as x approaches 3 of x squared minus 6x, what you can do is you can separate this and look at this as the limit as x approaches 3 of x squared, and then subtract the limit as x approaches 3 of 6x. Now, in this case, there's no real benefit to doing this, but just know that we can separate things that are added or subtracted into their own limit. Sometimes that's helpful. Property number 2 always would be kind of this similar idea, where we have the limit as x approaches a of some constant. So c here is some constant times a function. What you can do is you can take that constant c and bring it out in front of the limit. So you can have the constant times the limit as x approaches a of f of x. All right, one of the problems that we might see is something like this. The limit as x approaches 0 of sine x over 3x. So I have a 3 in the denominator. We can think of that as like 1 over 3. This is the same thing as I can pull the constant 1/3 out in front of the limit and make this 1/3 times the limit as x approaches 0 of sine x over x. I can bring the constant out front. Property number 3 of limits. What if you have 2 functions that are multiplied by each other? Right? Earlier we had them added or subtracted. If 2 functions are multiplied by each other, the limit of those functions as x approaches a can be thought of as the limit of the first function times the limit of the second function. We'll see that in an example that might look something like this. The limit as x approaches 0 of sine x cosine x. You can instead separate that and make that the limit as x goes to 0 of sine x times the limit as x goes to 0 of cosine x. Let me spend just a minute longer on this. What is the limit as x goes to 0 of sine x? All right, let's remember what sine of x looks like. Right, sine function starts here, goes up and down, curves, and as x goes to 0, the sine of x, the function value, is approaching from both sides a value of 0. So the limit as x goes to 0 of sine of x, the y values are going to 0. How about the limit as x goes to 0 of cosine x? Right, cosine x, remember, starts up here and looks more like that. As x goes to 0 in this case, right, as x goes to 0, the y value is going to 1. So the limit as x goes to 0 of the cosine of x is 1, and 0 times 1 is 0. And so in this case, you can kind of see the benefit of separating those into 2 different limits, evaluating each one, and then multiplying the results. All right, number 4. Similar to multiplying, you would think also this would work with dividing. The limit as x goes to a of f of x divided by g of x can be broken up into the limit as x goes to a of f of x divided by the limit as x goes to a of g of x. I should add on there, provided that the limit, let's let's do this. Provided that the limit as x goes to a of g of x is not equal to 0, because if it is, divided by 0, undefined. But anyway, you can separate that, and that one's really helpful, right? If you have, I think that was number 4, the limit as x goes to, make it 0, sine of x over 1 plus x. Right? If you had to evaluate all this together, it could be complicated. But what we can do is we can take the limit as x goes to 0 of sine x separately from the limit as x goes to 0 of 1 plus x. And honestly, we end up kind of doing this in our head, right? We often don't write this down. We just think, okay, I'm going to let x go to 0 in sine of x. Well, as x goes to 0, the sine of x also goes to 0. And then, in my denominator, 1 plus 0, we can do some direct substitution there, is just 1. And without even writing this middle step so much, we're using the property to say that we have 0 over 1, which is 0. And this is what often happens, is we don't write the property necessarily, but we're doing that middle step in our head. Okay, finally, and sometimes though, sometimes it is helpful to write it out, like in number 3, that might have been helpful for us. Number 5, if we have a function raised to some power, this one's interesting. The limit of some function raised to the power. So the limit is x approaches 3 of x to the 5th, right? We could take the limit as x approaches 3 of x and then raise that result to the 5th. The limit can go on the inside part of that. Right, so something like the limit as x approaches 3 of x to the 5th, I think I said. We could think of it like that, or we could think of it like this. What is the limit as x approaches 3 of x, and then raise that result to the 5th. Either way, you get the same answer. All right, that is all for our properties of limits.